Okay, so good day and welcome class to our session for today, Computer Software in Structural Analysis. So this time we are going to tackle on application of Staadframe on building frame system. So of course we are going to utilize our initial learnings on the previous sessions regarding the Staadframe workflow process and model generation with the four methods flashed in the slide, and then the property assignment. So yung property natin will be defined as a cross section since our focus here is building framing system. And then we will define loads. So our focus in load definition is more on seismic or earthquake loading based from the UBC 1997. And then load placement, of course, typical load cases like self-weight, dead loads, live loads. Ang may singit lang dito is yung earthquake load along X and along Z direction. So later on, we are going to learn that one. And then the structural analysis, and then the post processor wherein we can see the results or the outputs, and we are going to perform reinforced concrete design in Staadframe as well as performing RC footing design. And as for our learning objectives, so number 1, at the end of this session, you will be able to construct structural models of building frames in STAAD using various methods or the combination. Number 2, utilize group tool in the establishing of structural model of building frames. And then number 3, assign properties to structural models. And then execute structural analysis to building frame models. So next, perform RC design on building frames using Staadframe, and then perform RC footing design on building frames using Staadframe. So as a prerequisite, of course, it is assumed that we recall our learnings on the relevant codes on loadings or the provision of the National Code of the Philippines on loadings and seismic provisions. So first, we need to recall this, those are the load combination, but this time, yung panglima dito is our focus since we are on building frame system. Okay, so that is the load combination is 1.2 dead load plus 1.2 live load plus 1 earthquake load. So those that will be our focus. So of course we have here the computation of base shear in earthquake engineering. So it is actually V, or the maximum lateral force that will occur due to seismic ground motion at the base of the structure. So this is according to NSCP equation 208-8 that was adopted on the UBC 1997 code. So that is the equation which includes the parameters. First, we have CV, or the seismic coefficient, depends on soil type, the seismic zone, and the I is the seismic importance factor. So this is dependent dependent on the occupancy of the structure, whether it is residential or hospital or hardware, library, and among others. And then R is the response modification factor. So it depends on the type of the building. We have R for special moment resisting frame ng RC, and then structural steel system, and we also have masonry system, and we have wood. Okay, and then we have here the seismic time period of the structure, and lastly the input parameter is W. Another input parameter is W, or total dead load of the structure, or what we call the self-weight and permanent permanent elements on the structure. So again, this is just to present the formula. Although yung STAAD, it will compute for us. Okay? STAAD will do the computation and analysis for us. Ito yung importante, yung input parameters. So by this, we need to recall all of the relevant section of our NSCP. So this is our reference, NSCP 2015. So meron tayong I, seismic importance factor that could be found on 208-1 table, and then R, response modification factor, and then we have the seismic time period of the structure. Could be method A or method B. So our focus here is method A, method A tayo. Okay, so those are the notations. So on seismic importance factor, we can find that in table 208-1. So for purposes of earthquake resistant design, each structure shall be placed in one of the occupancy categories listed in table 103-1. Table 208-1 assigns importance factor I and IP, I sub P, and structural observation requirements for each category. Okay? So yan yung mga importance factor. Dito we will identical naman yung importance factor ng I dun sa I sub P, depending on the occupancy category. You can recall that we have also used these categories in our wind load generation last time. So another table found in the Structural Code of the Philippines is the soil profile types. Of course, you have an initial reconnaissance of your soil or subsoil, So if you have identified that, of course, you refer to the table. So merong hard rock, and then very dense stiff soil profile. So yan yung mga profile, SA, SB, SD, SD, until SF. Okay? And then we also have here another table. Ito, input parameters din to sa seismic zone. So zone 2 and zone 4. So the Philippine archipelago is divided into two seismic zones only, Zone 2 covers the provinces of Palawan, except Busuanga, Sulu, and Tawi-Tawi, while the rest of the country is under Zone 4, as shown in Figure 208-1. Each structure shall be assigned a seismic zone factor Z in accordance with the table. So, dalawa lang ang zone natin, Zone 2 tsaka Zone 4. So, majority of the Philippine archipelago is on Zone 4. So, as you can see here, yan lang yung mga Zone 2. Okay? So, we also have a reference here, the distribution of active faults and trenches in the Philippines. So, ito magagamit natin on the near source factor, which in a while I will flash it for you. So specifically, each of the region has also active faults, okay, outlined or drawn in our structural code. Okay, so I have here the active faults of Cordillera Administrative Region. So yan, we need to use that in the near source factor, referring to the distance of the nearest fault, okay, or the nearest seismic source. Okay, so those are the values. So it could be either seismic source type ABC with the following ranges of the distances. Okay, so the near source factor may be based on the linear interpolation of values for distances other than those shown in the table. The closest distance to seismic source shall be taken as the minimum distance between the site and the area described by the vertical projection of the source on the surface. Okay, the surface projection need not include portions of the source depths of 10 kilometers or greater. So yun ang notes na near source factor NA at near source factor NV. Okay, now we also have here the response modification factors. So this is for reinforced concrete, ano? So normally we are on letter D, ano? You can use dual system if yung building mo is a combination of shear walls. Okay, this is true to most of the structures today. Yung mga large structure, it composes of shear wall and combination of RC columns, ano. So ang usual na ginagamit sa letter C or the moment resisting frame system is yung SRMF or special reinforced concrete moment frames that has a value of 8.5. Okay, so if you have some structures, structural framing system, you may refer to this kapag RC, ano? Okay, and then take note that there will be system limitation and building height limitation according to seismic zone. Okay, so we also have here R or response modification factor for steel structural system. Ayan, meron din yan. This is just a continuation of this, and then we also have response modification factor for masonry and wall. So we also have to take note of structure period. So sabi ko nga kanina, method A ang gagamitin natin. For all buildings, the value T may be approximated from the following equation. So there are constant or CT dito na kapag RC moment resisting frame and eccentrically braced frame 0.0731, kapag steel 0.0853, and for all other buildings defined in R 0.0488, at yung H dito yung height ng building raised to 0.75 or 3/4. Okay, so of course, let us not forget our basic loadings. So makikita natin yung mga corresponding weight and density of any material. This is outlined in NCP. So design dead loads as well. So it's nice to have this for our CHB partition. Ito, concrete masonry units. Kung yung grout spacing with a density of 16.5 kN per cubic meter, okay, and 19.6 kN per cubic meter, then 21.2 kN per cubic meter. So whether it is fully grouted, no, or no grout, okay, so those are the density. This is in kilonewton per cubic meter, no, remember. And then we'll just have to add 0.24 kilopascal for each face plastered. So we also have these inputs, the minimum uniform and concentrated live loads. So it depends on the occupancy or the use. Okay. So we also have here the special loads. So those are the essential loads you need to recall. Okay, so let's now get started on modeling our frame. Okay, so for your appreciation of the procedure, of course, we should base from the floor plan or from the architectural plans of a certain structure, no? So this time, I have here a residential building, 2-story. So from the floor plan, we can see here the typical occupancy or circulation of this residential building. May bedroom, dining, kitchen, and then on the second floor, meron tayong stairwell. Kapag may stairwell, of course, you know that walang slab dyan, no? So may terrace, and we have here an overhang on that section. So basically, what we need here are the dimensions and the framing system. Of course, you should draft that first, your framing system, in order to come up with the structural model. Okay. So from this plan, drinaf ko to and came up with framing system. So sa foundation plan, we have here tie beams. Of course, I have here the tie beams, the layout of the tie beams. And then for this, the first, parang ito yung framing system mo ng first floor or the first level framing system. And then we also have framing system for second floor. Yan. As you can see here, yung mga cantilever slab dyan. Then connecting beams on the smaller columns. So we better take note of our partition, Naka-outline din yung mga partition dyan. It is not necessary to make beams sa mga partition, You can incorporate itong mga partition. Halimbawa, itong partition na to, wala naman dyang beam, di ba? So, ang gagawin lang dyan, may stiffener column ka dito. Okay? And then incorporate those loadings in your S1 or the slab design of your S1 dito. Okay? So again, the configuration will be depending on the architectural plan, but not necessary na may beam in every partitions. Okay, so here wala tayong slab because this is a stairwell, no? Okay, and then meron din tayong roof framing plan. Of course, kailangan mabracean yung columns natin on the roof level. Although ito, we have the truss loadings. By the way, sa truss loadings, it will depend on your truss analysis na natutunan natin in the previous sessions. So what we have to do is, kung ano mang reaction ng truss dun sa analysis mo, just make it a joint load on the columns on the roof level. Okay, so let's start. Okay, so we open the Staadframe and then we will make a new, say this is a frame exercise. We open our Staad and then we click space truss and meter kilonewton, then next, and then we will start our worksheet with the add beam. Okay, so yan. Okay, so we start with the XZ plane, no? Sa XZ plane, for this method I'm going to utilize snap node beam. Okay, or pwede rin by coordinate method. Sa snap node beam, so alam naman natin, just have to create members here. So we will refer to the foundation muna. Ito. So with the foundation, you can see here, say we set this as our first grid along longitudinal, then this is the transverse grid. So yung una ito, and then 4 meters yung distance nya, another 4 meters, 3.5 naman yung horizontal layout. Okay, so meron tayong column na hindi tapat nung C3. Okay, medyo nag-list siya ng 1.3 meters. So to do this, create node ka muna dito, and then this is 3.5, ano. Of course, you need to set your spacing along X na 0.5, 0.5 din yun. Okay, and then you just add spaces here. Okay, and then snap node beam, this is 1, 2, 3.5. yan. And then i-create mo rin yun, 3.5 din yun. Okay, snap node beam hanggang 3.5, say 1, 2, 3.5. okay, so dito I'll just select these members and then use this translational repeat along Z direction, number of steps na 4 meters, 2, so this is 4, and add here another 4 meters. We click these link steps. Okay. So, yun. Kapag hindi mo click yung link steps, wala tong mga members na to. Okay. So, you should have to click link step. So, ilang distance, if you notice, may leeway akong distance dito, no? What for? Kasi nga, iniiwasan natin na magkaroon ng negative nodes later on. So, if you want to incorporate cantilever beam, pwede mong incorporate na dun sa pinaka-base. Kasi ito, I will use translational repeat along the vertical. Mamaya. Okay? So, if you want to incorporate yung cantilever beam, ilan ba yung cantilever beam dito? So, that is 1.2 meters. Okay? So, 1.2 meters yung cantilever beam. And by the way, ito, medyo nag-list siya ng 1.3. Okay? So, you should offset this node to. Just click that node, you know? Just save that. Kailangan tayong mag-offset ng 1.3 dito along what axis? X axis, ano? 1.3. So, yung X node or X coordinate is 9 plus 1.3, that would be 10.3. So, ang gagawin mo, close mo muna to, and then, copyain mo yung mga node dito. Itong X dito, magiging 10.3. Ang Y mo, 0. Ang Z mo is parehas lang na 2. So, if you notice, we have just inputted a node here. Yun na yun. Lumabas na siya, and then we'll just have to add beam here. Okay, so that's one way to do it. So, ngayon, tingnan natin yung framing system. Okay. May mga cantilever beam dyan. Okay. So, what we do, i-offset natin lahat ng to, taas, and then we'll just have to delete it later. So, another technique here is the copy paste. Just click that one, Control C, Control V, and then reference point, okay, and then just click this, and okay, and then Control V again, reference point, okay, and then just click that one, then okay. So, meron na tayong cantilever beams dyan. We just have to connect that one. Okay. And then, incorporate na rin natin yung cantilever beam ng ating second floor. So, on second floor, you can see here, 1.2, tapat siya ng columns dito. So, yung column dito, yung sagad dito. Okay, yung dulo ng, or corner, column. Okay, hindi dito sa grid na to, no? Okay. So, may cantilever beam tayo. Again, just click that node, and then, saan tayo mag-offset? Along Z, di ba? Yung Z natin dito is 10. Okay? 10. So, basically, 10 minus 1.2, that should be 8.8. Okay? Then, Y is 0, and X shall remain to be 5.5. So, anong nangyari? Okay, so, delete muna natin itong node na to. So, mag-offset tayo sa Z ng pababa. Yung Z pala 2, sorry. Kaya pala napunta dito yung 8.8 kanina. So, copy mo yung X kasi the same ano yan. Then, 0 yung Y. At yung Z is 2 minus 1.2. That is 0.8. So, yan. So, lumabas na yung node dito. Then, we'll just have to connect that one. Okay, we connect that one. So, next, we copy this. Control C. Then, Control V. Reference point. Okay, and then just click this one. Okay, yan. Control V again. Reference point. Okay, and then just click this one. Okay. Then here, we connect these members or nodes. Okay, so this is the framing system of the second floor, diba? So what we do is to offset this vertically kasi ito yung plane ng XZ, ano? Kung titignan natin, yan yun. Okay. Isometric view. And then you go back to that. Before we will proceed further, gamitin muna natin yung check duplicate. So far, wala namang nodes duplication. Ganun din yung members. Okay? And then we select all of this. And then again, translational repeat tayo. On Y, sa unang offset natin, yun yung from footing up to the first floor. So, ilan ba yung hukay mo or the depth of your excavation on your plan? So, kung titignan natin dito sa sa tapos ng design, ang depth ng footing is referred to the table. Ito yung typical column section detail. So, ito yung footing schedule. Ito. Yung depth is 1.5, ano? So, 1.5 yung major columns mo. So, yung unang offset is 1.5. So, for the meantime, we click the link step para mag-connect lahat ng nodes vertically. So, yung unang space mo or vertical offset is 1.5. So, that is from footing up to the first floor. Kasi, yung structure ko dito, no? Yung first or yung tie beams mo nakatutok sa ground floor. Okay? Tutok ko yung tie beam ko sa ground floor. So 2.5 yan. 2.5 na yan, ano? Depth of from the finish grade line. Ngayon, magpa-plus pa tayo dun sa backfill, no? So the finish floor line kasi nga sabi nga natin tutok yung tie beam dun sa finish floor line ng ground floor, hindi sa natural grade line. So we will look into the elevation. Ilan ba yung backfill na ginamit? So kung titignan natin dito sa elevation plan, okay, ito yun. From our natural grade line up to the finish floor line is this one, 400. So, yun yung may dadagdag. Okay? So, 2.5 plus 400. 1.5 plus 400, that is 1.9. Okay, we take this one for another step vertically. Sa second floor naman, anong elevation niya from ground up to the second floor level? So, dito sa plano, the second floor level is this one, 3 meters. 3 meters din hanggang dun sa roof beam. Okay, ito kasi, ano na to, the top of the highest king post. So, sagti 3 na yan. Okay. So, we have sagti 3 na to. Then, another step for the roof beam. 3 meters din. And we just click OK. So, kung titignan natin, yan na yung model mo. And then, while this one is highlighted, press delete button para mag-delete yan kasi wala naman tayong framing sa mismong footing. Okay, so that's it. So that will be the initial step. So ngayon, pwede mong view from the XZ plane, tapos you may press arrow buttons, okay, to rotate globally. Okay, so ito hindi pa to final na frame natin. So ang gagawin mo, view muna dito, magsimula ka in editing your first level. So just click this one. Okay, ito, long click to, hold your left mouse, then yan. So, ang pag-select is from right to left, from right to left. Okay, from right to left, isama mo yung column sa baba. So, from that, we will proceed to the view, and then view selected objects only, and balik ka dito sa view na to, then use the arrowheads again, to edit your structure. So, kung mapapansin nyo, madali na lang mag-select dito kasi na-call out yung view natin. So, mangyari, I think we need to refer to the floor plan. Alam natin na ito cantilever yan, kaya walang poste dyan. There's no column there. So, you select those columns and then just delete that. This time we're going to delete the columns that are needed here. Okay. So, first, we know that these are cantilever beams. So, when you select a member, to madidelete yan. We select all the members to be deleted. Select the first column and then hold control and then delete the others. So, alam natin na wala yan. What else? Ito, naka-hold yung control dito, no? And then, wala rin yung column na yan. Okay. And ito, wala rin yan. Okay. So, we delete all of those columns. Okay. So, next, so we are on the ground floor, no? Remember, hindi naman natin kailangan ng cantilever beams sa ground floor. So, we need to delete those cantilever beams also. So, we're going to delete also yung cantilever beams dito, no? Ground floor. So, wala tayong cantilever sa ground floor. We do not need those ones. Okay. So, if you accidentally selected undesired members, halimbawa na-select mo yan, naka-hold yung control dito, then just unselected to add. Okay. Wala to mga beams na to. So we delete those beams. 9 beams to be deleted, then okay. Okay. So if you notice, may mga naiwang nodes dyan because we haven't deleted yet yung mga second floor members na naka-attach dito sa node na to. That is why it is appearing on your screen. So, but don't worry about that. We will proceed to the second floor and then eventually matatanggal din yung mga nodes na yan. Okay? So what you do is to highlight this and then just click this one, display whole structure. Yan. If you notice, yan yung na-edit mo. Okay. So you use the arrowhead to rotate. So of course, hindi pa may floating na column, ano? Ito yung sinasabi ko, naka-attach pa rin yung nodes na yan. Okay. So, para mas madali, again, you isolate the second floor, including its columns. Then view, selected objects only. Then ito. Then use the arrowhead to rotate vertically and horizontally. Then again, delete undesired members here. Or members that are not included in your framing system. So ito, wala yung member na yan. Then hold again control. Wala rin yung member na yan. Wala din to, wala rin yung. Of course, ito yung naiiwan sa corner. Then those columns. So deleting beams has left some nodes with no structural element attached. Do you want to delete this node? Of course, yes. So yun. Tanggal na yung nodes na yan. Okay. So, may naiwang node dito kasi nga may beam ka kanina dito connecting these two columns. That is a tie beam actually. So, do not delete cantilever beams dito kasi overhang na yan. Second floor na tayo. Okay? So, that's it for the second floor. Then we display again the whole structure and click this side view. Select the third floor including the columns. And then view. View selected objects only. Ito. Yan. Use the arrowheads on your keyboard. Then press this one, press control, hold control. Then select yung mga beams na hindi kailangan or members na hindi kailangan. Okay. So those are the beams or columns that we do not need. Delete, press delete, then okay. So yan. So we are done with our modeling. So if you want to check your model according to floor plan, say side view ulit, yan, select mo yan, do not include the beam this time, then view, selected objects only. So check natin sa floor framing system. So tama naman. I will not include here itong minor framing system kasi parang extension lang yan. Actually hanggang second floor lang yan. So ang lalabas dito parang magko-connect lang yan on the second floor, but for sake of analysis I will just neglect this. Okay? So tama naman yung nagawa nating model. Ayan. On the ground level. And then for the second floor, select that one and then view. Selected objects only. Check natin. Second floor framing system. Yan yung itsura ng second floor framing system. So, supposedly walang beam dito, no? On our model. Delete to. And press OK. Yan. Dire-diretso naman yung framing system. And then, ganun din sa third floor. So, sa third floor pala, you just maintain the cantilever beam here, pero wala na rin dito. Kasi ang bulada manggagaling na sa, or the eaves will come from the purlins. Parang may yung purlins mo nang mag-overhang dyan to cover the needed shed here. Okay? So, may iwan yung cantilever beam na dalawa dito. So, on third floor, we select the third floor frame, view, selected objects only. Tanggal tong lahat. Then just press delete. Tapos to, cantilever beams. Tatlo. Lahat to. What else? We have a cantilever beam here. So, dito nawala na yung column dito, class. Column here. Kumbaga, putol yung column dito because titingnan natin sa floor plan. Hanggang terrace na lang. So, sa terrace, parang hindi dumiretso yung shed niya. Okay? That is why wala ditong column. So, we need to delete that column. So, basically, we still need to include the column here. View selected objects only. Then, this one. Wala ito. And then, I think wala rin itong mga to. Okay. Wala na rin to. And then dito meron tayong cantilever. So, we need to get the dimension. So, I think this is 1.2. Hindi kasi naka-scale to. 1.2 rin yan. So, we have 1.2. So, ito. select that node. Okay. So, saan tayo mag-offset dyan? Siguro mas maganda ito. Select natin yan din, this one. Saan tayo mag-offset? Along Z. 6 yung Z. Dapat 6 minus 1.2. Yun ay 4.8. And then yung Y parehas. 4.9. Parehas din yung X na 9. Okay, so yan, we have just created a node here, and then just connect that one sa cantilever beam. Okay, so okay na yung model natin, ano? So we have generated the model. So what is next is to define our properties. Okay, so to define our properties. So here I have assumed the same cross section pero nag-iba lang yung mga bakad. So kung mapapansin nyo, lahat ng section ko is 250 by 350, most of the beam sa second floor tsaka sa third floor, as well as the cantilever. Pwera lang sa ground tie beam, 250 by 400. So 250 by 400 yung mga ground tie beam. Okay, 250 by 350 yung mga upper beams natin, 250 by 350 for the upper beams, and 250 by 400 for the ground tie beams. So we view the whole structure, and then ganun pa rin procedure. So we use the beams cursor here, then punta na tayo sa geometry, then general. So property na tayo, punta tayo sa define. Okay, so ang gusto mong i-define is yung beams. By the way, yung column natin is 350 by 350. Okay, so 350 by 350, a rectangular column, 0.35 by 0.35. So yung material natin of course is concrete, no? Then we just add that for the meantime. And then dito 250 by 350 yung beam ng upper beams, but dito 0.4 na yung sa tie beam natin. So we just add those ones. So lahat na na-define dito. Una muna yung column. So you select all the columns. Okay, then hold control, hold control. And then just assign, press assign here, or assign to selected beams. Check that one, assign to select, then assign. Okay, so that's one way to do it. Ngayon, kung puro vertical lang naman yan, so we just select, we go to the select tab, and then beams parallel to select Y. So lahat ng Y na select na. So we can check that by perspective view. So anyway, na select na yan. Okay, so we select assign, we tick assign. So na-assign na yung mga columns natin. So then uncheck all of the structure. You can check the assigned members in this 3D rendered view. So if you notice, wala namang so far, wala namang member na or column na hindi na naka-assign. So all of the columns were assigned. Okay, okay with that. Then we just close this one. So we proceed to ito, 0.25 by 0.4 are the members for the tie beams. Again, we select all of the tie beams, then assign. So ito naman, the upper floor, select that one, then again hold control dito, no? Okay, select the level, the third floor level, then assign. Yes. So we can check that again to the rendered view. Yan. So kung mapapansin nyo class, yung node connection is nasa gitna. Kaya kung titignan nyo, may nosing siya doon. Pero dapat, di ba, flat. Flat lang yan dapat. Ito. Ito dapat flat lang yan. Dapat ito nakababa. Kasi nga, center to center yung reference niya. Dapat itong mga beams bumaba by half of the dimension of the depth of the beam. Okay? Parehas din sa lahat. Okay? So, ang gagawin nyo dyan is punta ka sa ano. So, basically, nasa geometry pa lang, general tayo. And then, skip muna yung geometry, no? Balik, general. Punta ka dito sa specs. And then, select this one first. Select. Then, punta ka dito sa beam. Offset. Saan ka mag-offset? Along Y, di ba? By how much? 0.2. Half of 0.4, di ba? 0.2. And then, assign. Okay. By the way, yung location kasi kanina naka-check na offset is start. And then, kaya yung mga beam banking, medyo tabingi. I-apply mo rin yan sa end, di ba? Location end, and then by Y, 0.2 pa rin. And assign. Yan, pumantay na. Okay? So, we do the same to these beams. Okay? Then, beam, start end, offset, start muna sa Y. Ano yung half ng 350? 175, di ba? So, 0.175 and then assign. Okay. And then, again, add another one offset. This time, end na. And then, 0.175 and then assign. Okay, pantay na. Kaya kung titignan natin dito, tumaas. Okay. So, supposedly dapat yung ating offset is negative, ano? I'll just want to present that one. Kasi positive yung input natin, kaya yan, nagkaroon pa rin ng nosing. Pero dapat flat yan dito sa column. So, what you do, although we have a mistake on the input, you can just edit that one. Okay. Lagyan mo lang ng negative sign dito. Negative. Sorry, negative. And then change. And then double click that one. Then negative din yan. Negative. So, lahat negative, ano? So, do the same for the rest. Negative. Okay, we check again. Yun na. Sakto na yung pagka-flat ng connections. Okay? So, again, dito, meron pa rin tayong nosing. Diba? Because of this cantilever beam. So, dapat, supposedly, patras natin tong beam na to, on the cantilever, by half of the width of the beam. Ano yung width ng beam? 250. So, 0.125 yan. So, again, we apply that to this beam. View selected objects only. Saan mo i-apply yan? Dito. Sa cantilever beam. Ito ang problema. Dapat ito, class, buo yan. So, first, we must have to correct that one. Just select that one, then delete. Okay. Then create another beam here. Yan, para mabuo. So, ngayon, nagkamali tayo. Binuo natin yan. Kasi hindi pwedeng may node doon na buong beam. Of course, may instability doon. So, you need to go back to general and then property. Wala na siyang naka-assign kasi new member yan. What you do is to select that one and then hold control and then select this one and then assign it again. So, masasama na yan. That will be included again. So, yun. Ito, balik ka dito sa specs. Offset natin yung beam by start and end. Start muna tayo. Ngayon, we're gonna offset that along Z 0.125 or half of 250. Then, assign. So, tingnan mo, pumasok na siya doon. And then, beam again. Set Z negative 0.125. Then, sorry, 125. And dapat to. And, at ito positive. Z start and end. So if we check that in the rendered view, kung titignan natin, kasi nga bagong add yan kanina, hindi rin siya na-include dun sa dito. Yung in-offset natin kanina, kaya kung titignan mo, hindi pa rin naka-offset yan sa Y direction. So anyway, half lang pala yung ginawa natin, but supposedly buo dapat yan. 0.25. Change. And then this is 0.25. Change. Okay. So if we need to view that, we have this to be corrected. Sige, let us ayusin muna natin yung Y nya. So sa Y, negative 0.175. Change. Balik mo ta sa 0. Negative 0.175. Change. Okay. And then, balik ka dito. Okay, I think sign. Yan. Okay. So ngayon ipasok natin tong beam na to inwards. Half of 0.25 along itong blue axis. Ano yung blue axis? Z direction. Negative 0.125. So, set, start, negative 0.125, then add for a while, and then another one, offset, negative 0.125, and then add. Select this one, assign, then assign. End up. Okay, so let us again offset this beam. Okay, so along Z direction yan, ano? So this beam. So click beam and offset. Start. So half of the dimension of 250 negative, or tingnan natin positive, no, positive. It is going upwards. 0.125. So we assign. Then end 0.125, then assign. We assign this. Okay. Okay, so we have assigned here Z direction 1.25 and end for 125 for this beam. So if we are going to check that, pumasok na siya, but yun, nawala yung offset niya along Y. So I think we should add another Y here na negative 0.175. Just change that one. And end negative 0.175. Change. Okay, let's check. So yun, okay na, pumasok na siya pa Z, and then bumaba na rin siya at the level of the beams on the second level. Okay, so we do the same to this beam. To pasok natin pa ganon. So what direction? Along red axis. Yung red axis is X. Okay, so we go back to specs. So we select this one. To check natin. So lahat yung beam na yan, pasok natin pag ganun. Okay, dapat pumasok siyang pag ganun. So dapat kasama yon lahat. So, ito lahat, pasok natin along x direction. So, let us try negative. Ito yung x kasi. So, by how much? So, the dimension of this beam is 250. So, by 125, offset negative 0.125, tapos yung y niya kanina rin negative 0.175, negative, so sign, and then click this again, then end naman, this is negative 0.175, this is negative 0.125, sign. Okay, let us check. So, kung titignan natin, ayos na yung pagkaka-joining ng beams. Okay? So, if you notice, naka-connect to dyan. Pero, hindi siya naka-flash dito sa dimension. Okay? So, if that is the case, perhaps we can change our x to positive. Close muna natin yan. Change. Pati rin yung end. Change. So, let's check. So, ayan. Connected pa rin sila. Okay? Problema ito, may release. So, okay naman siya dito. So, let us try to offset this beam para tumama siya doon. Okay? So, what's that beam? Yung beam sa likod. This one. By z direction. By how much? By half of the dimension of the beam. So, marami to consideration. So, beam, offset. So, dati nang may 0.175. And then, along x, negative 0.125. And z, is positive 125. Let's try to assign that. Nag-offset siyang paganyan. So I'll just change this to positive 125. Change. And then we check. Okay na. So in-offset ko yung start nito at the half of the dimension of this sa z direction to, no? Kung titingnan natin. Ayun, yung blue axis. That one. The blue axis, parang in-stretch ko lang yan ng 0.175. Start. Okay, so hanapin pa natin kung meron tayong nosing. So wala nang nosing, no? So all of the connections are exactly placed on your model. So I think this model will now be ready for loading, and that will be our next session, the placement of the loading and the seismic definition. So with this, so I hope you appreciated the modeling procedure of our framing system. Okay, so see you next session and have